We're going to do the last part of Calvin cycle. That part is called the regeneration of ribulose biphosphate. So let me remind you what we did in the last video. We basically did the following. Okay, so let me. Okay, so this is what we did. At the last step, we synthesized the following molecule. It's basically glyceraldehyde 3-phosphate. We synthesized this glyceraldehyde 3-phosphate. So this is the second step, and now we're going to talk about the third step in the Calvin cycle. The third step in the Calvin cycle is called the regeneration. So let me write down the name of this. It's called the regeneration of RUBP. It's a shorthand notation for ribulose 1,5-biphosphate. Okay, that's his third step. The first step, we did carbon fixation. The next step was reducing to form glyceraldehyde 3-phosphate. And now we are going to regenerate this particular compound, RUBP, because this is a cycle. If the entire thing is used, then it has to be regenerated again, because that's the important thing. You have to regenerate this compound so that the cycle should continue. So that's why we have to regenerate this. So we actually so the compound, the product formed by the last step, the recent step, the reduction, the compound formed was G3P, glyceraldehyde 3-phosphate. So this is what that was formed in the last step. So the structure of the following compound is the following. And so this is the structure of glyceraldehyde 3-phosphate. Okay, this is the structure of this. Okay, this is the structure of G3P. So once we have G3P, the problem is, how can you regenerate ribulose biphosphate? Now this is actually formed by two steps. If you remember, in the first step, we actually took this molecule. Okay, we took this molecule. We reacted it with CO2 in the presence of an enzyme, and this enzyme actually formed. This enzyme actually formed indiol intermediate, which was broken down to get 3-phosphoglyceric acid. And once you get this 3-phosphoglyceric acid, what we did was we again phosphorylized it in the presence of an enzyme again. I'm not going to mention the enzyme because I think most of you know it. I'm just telling you the overview. We used an enzyme, a phospholytic enzyme, to convert it into a biphosphate. And by converting it to a biphosphate, we reduced it in the presence of NADPH, in the presence of an enzyme again, to form this particular molecule. Okay, so this is how we got here. Because this is a cycle, this gets used up. This is the starting step of the Calvin cycle. So this gets used up. Okay, so how do we regenerate this compound? So that's what we're going to do. So this has a very, very complicated steps involving lots of enzymes. So let's get started. This is broken down into a lot of steps. Let me write down the first step of this. So we use something called triose phosphate isomerase. So got the spelling wrong. So this enzyme converts G3P reversibly to dihydroxyacetone phosphate. Okay, the enzyme is the following. This is the enzyme. This converts triose phosphate isomerase is the enzyme which converts this G3P. So this is G3P, glyceraldehyde 3-phosphate. You see, glyceraldehyde 3-phosphate. This is converted to dihydroxyacetone phosphate. So what's the structure of this dihydroxyacetone phosphate? Let me write down the structure.